Today we're going to look at solving linear inequalities. So because we're going to solve inequalities, that means our problem will have one of these four symbols in it instead of an equal sign. So less than or equal to, greater than or equal to. So there's a couple examples of inequalities. The one on the left is just a true statement, 3 is less than 8. The one on the right has a variable in it. So it could be true if we pick a value for x that works. And we'll talk about a couple values that work and don't work in a second. So to figure out if a number is a solution, okay, so we're gonna try like the number 5 here in a second. To figure out if 5 is a solution, take the number 5. You're going to fill it in for the variable, and you're going to see if you get a true statement. If you plug it in and you get a true statement, then that means it is a solution. If you don't get a true statement, then it's not a solution. So let's try 5. What does 3 times 5 give me? Is 15 greater than 12? Yep. Then 5 is a solution. A solution. Let's try 7. What's 3 times 7? 21. And that's bigger than 12, so that's also a solution. How about 4? 3 times 4 is 12. Is 12 bigger than 12? No. So 4 is not a solution. Okay, so that's what it means to figure out if a number is a solution. Plug it in, see if you get a true statement. So when we deal with inequalities, we're going to be talking about two words quite a bit, and or. With conjunctions, does anybody know which one of those two words is connected with conjunctions? Yeah? It's not or. So it would be and, yeah, it's and. So conjunctions have to do with the word and. And it's when you take two inequalities and you put them together with the word and. Okay. Just like that. So that says x is greater than -1 and x is less than 3. Now, when you write a conjunction, a lot of times that's the long way to write it. They do it a shorter way. And the way you can do it shorter is to start with a letter in the middle, smaller number on the left, bigger number on the right, both inequalities pointing to the smaller number. And if you break it down, you can see each inequality in the combined one. So we have the x and the -1. There's the x and the -1. It's pointing towards the -1, and it's pointing towards the -1 there. We had the one with the x and the 3. And if you break that one down, there's the x and the 3, and it's pointing towards the x, pointing towards the x. So when you combine them together, one of the symbols does need to flip around because the letters flipped around. And that happens because you're putting the letter in the middle. So it's going to be on the right of one of the numbers and on the left of the other. Okay, any questions on that? So it's important to know how to combine those two into one, or take those two and separate the green and the black boxes back out. Okay, both ways. So what that basically means is that is an interval. That means you can pick a number between -1 and +3. Now, can you include the -1 and the +3? No, it's strictly less than inequalities. Okay? It's not equal to. whether an inequality is a less than or equal to, there's a word to describe it. When your inequality does not have any equal to's in it, that is called an open interval. And an open interval is one type of bounded interval. Okay, so what I'm going to do now is give you a few different words that are used to describe intervals. When you think of something being bounded, what do you think of? Like if there's bounds, like what do you think that means? Yeah?
They're tied together.
Okay, like tied together, yeah?
They're like boundaries.
Like boundaries, right? There's limits. There's an area that you can go. There's a space that is defined. When we have bounded intervals, what that means is that we start and we stop at a number. Our interval starts at a number, stops at a number. You might include or not include the number. That's different. But you start at a number and you stop at a number. Can anybody think of an interval that would have a symbol in it where it wouldn't be a number? What can we have in an interval besides a number? Yeah?
The infinity symbol.
Right. If we have an infinity symbol, that's unbounded. We'll talk about that after, because it goes on forever. But as long as our bounds are numbers, that's called a bounded interval. So the first type of bounded interval is a closed interval. When you put a bracket on the A and a bracket on the B, does that mean you include it or don't include it? You include it. So like if you wanted to think of it on a number line, it would look something like this. Include A, include B, shade everything in between. These represent the same two things. This is called an interval. This is called a graph. But it's two ways of saying the same thing. So when you include each endpoint, that's called closed. When you don't include each endpoint, that is open. So it looks very similar, except what kind of circle would you have on A and B this time? Open. Do not include A, do not include B, but you can include anything between. So there's open, there's closed, there's two other types. What else do you think you could have besides these two? No infinity symbols though, because that would be unbounded. Yeah?
You could have one where one is included and one is not included.
Yeah, you could have one included and you could have one not included. Okay, that would be considered like a half open interval. And there's two ways you could do a half open interval. You could be open on the right or open on the left. And if you were going to draw one of these, the A would have a filled in circle and the B would have an open circle. And the last one would look similar, so you could draw that one yourself. Okay, but just remember what these are called. That is an interval. That is a graph. So when I have you solve inequalities, I might ask you to write your answer a certain way. I might say graph your answer, or I might say write your answer as an interval. Okay, so those are all bounded. So we already know what symbol you're going to see when it's not this. You're going to see an infinity symbol. But what do you think the opposite of bounded is? Unbounded. So an unbounded interval has either an infinity or a negative infinity. When you draw an unbounded interval, it has an arrow that keeps going in one direction forever. So if I was going to do this one in the upper right, it has a filled in circle on the 5 because it's a bracket. Shade right. And because of that arrow, it means it never stops. So it is unbounded. Okay, I'll do one more for you. I'm not going to do all of them. This would be an open circle, shade right. So the different kinds of intervals you can have are closed circle, shade right, open circle, shade right. Closed circle, shade left, open circle, shade left. Or if your interval was negative infinity to infinity, that's an arrow both directions. Okay, so any question on the difference between the words bounded versus unbounded and open versus closed? They might ask you to describe an interval using those terms. Okay, so let's practice writing an answer to an inequality different ways. Okay, what is this called? That thing I just circled. Yeah, I was even looking for something just even, it could be more general. It's an interval. It is bounded though. Yes, it's an interval. What they want is an inequality. Okay? An inequality is something like that. So that's an inequality. That's an interval. That's a graph. So it's 3 different ways you can write answers. Okay, so they want an inequality. So we're going to start by picking a letter, and that's in the middle. What would go on the left? Or tell me what this part of the interval means. Yeah?
It's a greater than their equation.
Okay, let's just start with that. So we know x is greater than -3. And tell me what this part of the interval means. Yeah.
Less or equal to 5.
X is less than or equal to 5. That's perfectly fine. You've written your answer as an inequality. If they ask you to combine it, can somebody combine these 2 inequalities into one for me? Yeah.
-3 is less than or equal to x. I mean, less than x. And
Less than
then
x.
X is less than or equal to 5.
Yep. So -3 is less than x, which is less than or equal to 5. So inequality on the right, interval on the left. Questions on that? And it is bounded. That is a bounded interval. Is it half open, half closed, fully open, fully closed? What kind of interval is that?
It's half closed.
Half closed on which side?
On the left. The right.
No, half closed on the right. Half open, if you want to say it that way, on the left.
Half open. Okay, so when it has that parentheses, that's open.
The parenthesis is the side that's open.
Okay, all right. Thank you.
So you could say half open or half closed, but you need to tell me which side is
side.
which. Yeah. Okay. What kind of interval is this one? Bounded or unbounded? Unbounded. So what kind of number can you pick based on that interval? Yeah.
Anything -4 or higher.
Right. Anything -4 or higher. Since it is an unbounded interval, the inequality is usually shorter to write than a bounded one. You don't have to tell me that it's greater than or equal to 4 and less than infinity. Some people write that. I know -4 is less than infinity. I got that. So you just have to say that x is greater than or equal to -4. And how about this one? Bounded or unbounded? bounded, so it's going to be a little bit longer when we write the inequality. Open, closed, half open,
Closed.
fully closed. Yep. All right, let's see if we can jump right to the final answer with the x in the middle. Anyone think they could tell me how to rewrite that as an inequality, but I would like the x in the middle? Yeah.
Negative 8 is less than or equal to x, which is less than or equal to negative 3.
Perfect. There you go. Any question on that? All right. So we've tried writing some intervals. We've tried writing some inequalities from intervals. Let's try doing some graphs from inequalities. Okay. What kind of circle do we need to use for this one? Closed on what number?
2.
Closed on 2. Anything else I need to do? Shade to the
Right.
shade to the right. All numbers greater than or equal to 2. All right, let's try this one. Again, well, actually, let me ask you first. Is the top one bounded or unbounded? Unbounded. It goes on forever. Yep. Okay. This one. X is less than 5. What kind of circle do we need for this one?
Open circle.
Open on what number?
5.
5. And shade
To the left.
to the left. All the numbers smaller than 5. Perfect. Bounded or unbounded?
Unbounded.
Unbounded. Good. Okay, and this one. You tell me. What's my first step? Yeah.
Closed circle on -1.
Closed on -1. Okay.
Open on 3.
Open on 3.
And then shade in between.
Shade in between. Perfect. Bounded or unbounded? Bounded. Half open on the right. So any question on getting a graph from an inequality? Okay, so now we know different ways we can write our answer when we have an inequality. We can graph it, we can write it as an interval, or we can write an inequality with a less than or greater than sign. When you're solving inequalities, it's almost the same as equations. But does anybody remember, if you do something very specific, then you need to do something in your problem? And it has to do with arithmetic. Yeah?
Divide by -1 if to flip it.
If you can you say that again?
Divide by negative.
Divide by a negative?
Not -1, but divide by negative, then you have to flip the sign.
Okay, yep. If you divide by a negative, you have to flip the sign. Or what else? So it's either divide or multiply, either one. So if you multiply or divide by a negative, you need to flip the inequality symbol. All right. And sometimes you can avoid having a negative in the problem for a little bit and work around that. But sometimes you got to do it. You got to multiply or divide by a negative, and you got to flip the sign. Okay. So Nick, what would be my first step to solve example 3?
You would multiply 3 by x and -1.
Yep. And 3 times x is going to give me how much?
3x.
3 times -1?
-3.
-3, but let's do the +2 at the same time.
-1.
-1. Perfect. Okay. And depending on the next step is going to control whether or not we end up having to flip the sign in this problem. Who can tell me what they would do for the next step? Yeah. Okay. So we're going to subtract 3x from both sides. That's going to give me nothing there, 2x there. And what else could I do at the same time? I can subtract the 3x and
Subtract 6.
subtract the 6. So nothing there. All I did was adding and subtract. Well, all I actually did was subtracting. Do not flip the sign when you add or subtract. Okay, last step, divide by 2. And it's okay to leave your answer like that. I mean, I wouldn't mark that wrong. But I'd rather have the variable on the left. Can somebody rewrite that so the variable is on the left? Anthony?
X is less than or equal to, greater than or equal to -7/2.
Yep. So when we rewrite it with the variable on the left, the sign flips. Not because we divided by a negative. That's just a rewrite. That's all we did there. Okay. Any question on that? So we were able to avoid multiplying or dividing by a negative because of the step Tom gave us. He moved all the x's to the right instead of moving them to the left, which is fine. That worked out fine. So let's look at how we can solve an inequality on the graphing calculator. So there's two methods I'm going to show you for solving on the calculator. One of the methods involves calculating a root. If you are calculating a root or calculating a 0, then that means you need to get everything on one side and have 0 on the other. So that'll be your first step. Get everything on one side and 0 on the other. We're going to graph it and calculate the root. And then the answer is either going to be everything that is above the root or everything that is below the root, less than or greater than. We don't know which one it's going to be. It depends on what they asked for in the problem. So we're going to have to see, did the problem originally ask about greater than 0, which is positive, or less than 0, which is negative? Okay, so we're going to solve this one. Now, this isn't one that I would normally use a calculator on. I can solve that in my head a lot faster than graphing it. Just add 1 and divide by 4. Done. So when you solve this, that's the answer to the problem. X is less than 3/4. But what I want to do is show you how to do it on the calculator with an easy question. So that way when you have a harder one, if you can't figure it out, the calculator can help you. So it says to get 0 on one side of the inequality. Okay. How would I move everything to one side? Yeah.
Just subtract 2.
Right. It's not how you would solve it algebraically. Okay. But we're not solving it algebraically. We're using the calculator. So subtract 2. And you get 4x minus 3 is less than 0. Okay, so we did step 1. Now, put that in on the calculator. 4x minus 3. So 4x minus 3. Do zoom 6. There's your graph. And now we're going to calculate, what did I say? Calculate the root. Second calc, option 2. So pick a point that you know is to the left of your root, which means the y value is negative. Hit enter. Go to the right of your root, which means the y value is going to be positive. Hit enter. And then the guess, it doesn't really matter. Hit enter one more time. If you did all that right, you should have gotten this as your root. 0.75. Now, the answer is either everything less than 0.75 or more than 0.75. The original problem, look at what it says. Does it want to know where what I graphed in blue is above 0 or below 0? Below 0. Or is it less than 0? This is the part of the line in green that is less than 0. So think about which way you have to go from 0.75 to make sure you're on the green part of the line. Do you go to the left or do you go to the right? You go to the left. If you plug in a number to the right, like if you plug in 5 for x, and 5 is way up there somewhere. That's not what you want. You want to plug in numbers that are below 0.75, and that'll land you on the green line. And that's the answer. X is less than 0.75. Same thing I got when I did it in my head quickly. Okay, so that's one way to solve an inequality. Okay, calculate a root. Okay, second way. Instead of calculating a root and rearranging it so we get 0 on one side, we're just going to leave it the way it is. Whatever's on the left, leave it. Whatever's on the right, just leave it. Graph both sides the way it is. So this is the same problem we just did. I'm doing it one more time. This time, I'm going to type in 4x minus 1, put that in y1, and put 2 in y2. Okay, 4x minus 1, I'm doing in blue. 2, I'm doing in red. I'm looking for where the blue line is under the red line. Where is the blue less than the red? So let's hit graph. And this time I am not going to calculate a root. What do you think I'm going to calculate this time? Yeah, go ahead, Dave.
Intersection.
Yeah, this time I want to calculate an intersect. And then it's the same idea. Is your answer everything below the intersect, or is it everything above it? So let's do second calc intersect. Pick a point on the blue, hit enter. Pick a point anywhere on the red and hit enter. And your guess. Okay. So I got an intersection point. We already kind of knew what we were going to get there. 0.75. Okay, now we want to know where the blue is under the red. Where is the blue line under the red line? Is that as you head to the left of this intersection point or to the right? Yeah, it's down and to the left, but it's to the left. Okay? This is the part of the line I want to be on. So to be on that part of the line, the x values are below 0.75 for every coordinate that's on that line. If you picked where the x values are above 0.75, you would be on the top part of the blue line, and that would be above the red. They wanted below the red. So it's everything below 0.75. Okay, so that was the next question, but I pretty much just did it. I did example 5 right in the problem right there.
Just about that real quick.
Yeah, just a minute. Okay, so is there any question on method 1 or method 2 to solve an inequality? One uses roots, one uses intersects, but you can get the same answer. So do whichever method is easier for you. Okay, so the last thing we're going to start to look at is absolute value inequalities. And if you remember from absolute value equations, that's where you have to split it into two problems. So before we do an absolute value inequality, I'm going to start off with another type of inequality that's a little easier, but you still have to split it into two problems. Okay, so this is kind of a warm-up, splitting into two problems, and then we'll do the absolute value splitting into two. Okay, so double inequality. That's an example of a double, or I call it a compound inequality. And what you're going to do is split into two problems and then solve each one. So you're going to split it into two problems and solve. I'm not going to do the one that's up above. I have a different one. But that's just an example of what a double inequality looks like. So now, before I showed you guys how to take two that were separate and combine them, we're going to reverse it. We're going to take one that's combined and we're going to split it. Okay, so let's try this one. Split that into two problems. Anybody think they can give me the first problem that's going to split into? Yeah.
Negative 3 is less than 2x plus 5.
Perfect. So that's my first one. Remember, when you have a conjunction, which that's what that is, it's always the word and. When we deal with absolute value inequalities, that's not true. It could be an and, it also could be an or, and you can't mix them up. But I'm going to show you how to not mix them up. Okay, so there's your first one. What's the second one we're going to solve?
5 is greater than or equal to 2x plus 5 divided by 3.
Yeah, you can switch it the way you wrote it. Said it, Anthony, was fine. I'm just going to copy it down the way that it's written without switching the order around. I also like this because the x is already on the left for me, which is how I would prefer to leave my final answer. Okay. So it's going to be the exact same set of steps to solve each one. Okay. What would I do first on both sides of that inequality? Yep.
Multiply by 3.
Yep. So first thing we're going to do is times 3 times 3. That's going to cancel those 3's out. Okay. Now, I had a negative 3 on the left. Do I need to flip the inequality? Ariel, what do you think? No. I didn't multiply by a negative. I multiplied by positive 3. So no flip. Negative 9 is less than 2x plus 5. Okay. What would be my next step? Yeah.
Add 5 to both sides, or minus 5.
I was minus 5. That'll work. That'll work for us. So minus 5 on both sides. Negative 9 minus 5. Still no subtract. Still no flipping because I did not multiply or divide by a negative. And my last step.
Divide by 2.
Yep. And that's a positive 2. So that gives me negative 7 is less than x. Or the way I would prefer it, how would you write it with the variable on the left side? Yeah, next.
X is greater than negative 7.
Yes. Yeah, the one above it is not wrong. It's just that's not seen as often. Okay, don't forget to write the word and. And now solve the other one exactly the same way. Multiply both sides by 3. 2x plus 5 is less than or equal to 15. Minus your 5. And what am I going to get for my final answer? Yeah.
5.
X is what?
5. Or less than or equal to 5.
Less than or equal to 5. Yep. So greater than or equal to 7 and less than or equal to 5. That is an interval. Bounded or unbounded? Bounded, right? There's no infinity, so that is bounded. And is it open or closed?
Half
Well, or half open?
Half open.
Yeah, it's half open, in this case on the left. Okay, so that's splitting into 2 problems and solving. Any question on that one? Okay, so the last one is another splitting into 2 problems, but it's absolute value. So it takes a little bit more work to get the 2 equations we have to split it up into. Okay, the first thing is when you are solving an absolute value inequality, make sure the absolute value is isolated. That is an example of an absolute value that is isolated. It is by itself, and there's nothing else on the outside of the bars on the same side. Okay. And now we're going to split it into 2 problems. Does anyone remember from yesterday, we only had to do one thing to get the first one we split it into? Does anybody remember what you do to the original problem to get the first one that it splits into? Yeah?
You just write it down without the absolute value.
Yeah, just write it down without the bars. That's all you got to do for the first one. It's the same as the original problem, just take away the bars. Now, the second one had something extra we had to do yesterday. We had to take out the bars, but what else did we have to do to get the second one? Yeah?
Add a negative.
That the step could involve adding a negative. Maybe not always, though. Yeah?
Change the sign on the opposite side.
Yeah, change the sign of the number on the opposite side. Whether that means it's a negative and it becomes a positive, or it was a positive and then it becomes a negative, change the sign of the number. We don't have to do the same thing today, but there's one extra thing we have to do today. We'll get rid of the bars, we'll make the number on the other side a negative, and what do you have to do with inequalities when you make something a negative like that? Also have to flip the sign. Okay, so 3 things you have to do to get the other inequality. Remove the bars, flip the inequality, and change the number on the other side to its opposite. Okay, so this is the extra step that you didn't have yesterday because we had an equal sign, and you never flip an equal sign. But inequalities, you can flip. Now, I told you that the final answer is going to have one of 2 words in it. What are the 2 choices for the words we've been using when we write inequalities? And what's the other one? Or. So it's either going to have an and or it's going to have an or. And you can't just pick one. You have to get this right based on something in the problem. So what you do is you go back and look at the original problem. So like if we were going to do this one, that's my original problem. You look at this symbol. And depending on what that symbol is, it tells you if it's an and or if it's an or. If the original problem has a less than or a less than or equal to, then the final answer needs to have an and. If the original problem has a greater or greater than or equal to, the final answer has an or. And the way I remember that it's an or is instead of pronouncing this symbol as greater, pronounce it as greater. Think of it as it's a greater symbol. So the greater symbol has an or. If you say it that way, it might help you to remember. So greater is an or. less than is an and. Less than and. Greater or. Okay, so I have two. I have three of these, but we're gonna pick two. Do you want to do one that has a less than in the original problem, or greater than? Yeah, which one do you want to do? You want to do the greater? Okay, so we'll do example 8. Okay, so first step, make sure the absolute value is by itself. Is the absolute value by itself? Okay, then let's split it up. What's the first inequality that splits into? Yeah.
3x minus 2 is greater than 1.
3x minus 2 is greater, that should give you a hint, greater than 1. So what word am I going to use in this one? It's a greater. So it's an or. And what's the second inequality? You got to do 3 things. Yeah.
3x minus 2 is less than -1.
Yep. Get rid of the bars, flip, make the number on the opposite side negative. Okay, and now we solve it. So we get 3x is greater than 3 by adding 2 to each side, which means x is greater than 1. Yep. So x is greater than 1, or add 2 to both sides, and we get 3x is less than 1, which would mean x is less than, yep, 1/3. Perfect. And that word or is important. Okay, I could do a drop down where you have to pick on the test, and or. I might just have an empty box where you type in the word and or. Okay. Any question on that one? And if we had done the less than, it would have been the same idea, except you write and on the final answer instead of or. Okay, so last one. I don't think it's example 12 because we've skipped a few. Whatever example it is, that's fine. All right, so we have a fraction. Something divided by something. And the answer has to come out positive. It has to come out bigger than 0. Can somebody give me an example in a fraction of what type of number can you have in the top? What type of number can you have in the bottom? So that when you divide them, you get an answer bigger than 0. Yeah?
It has to be greater than -2.
So I'm looking for something a little bit more general.
Full positive?
Yeah, you could have, if you had a positive number in the top and a positive number in the bottom, then when you divide a positive by a positive, it will come out bigger than 0. Yep. Or, what else could you have? Yeah?
2 negatives.
Right. So in general, if you divide a negative number by another negative number, the answer will come out bigger than 0. So let's call this one case 1, where you divide 2 numbers and get a positive. This is case 2. One of these cases is impossible in this problem. Is it case 1 or case 2 that would never happen in this problem? Yeah?
Case 2.
Yeah, case 2 would never happen. Why would you never end up with a negative over a negative, no matter what you plug in for x?
Because it's absolute value, so it'll make, even if it's like 2 minus, or 3 minus, 1 minus 2 would be -1, but then the absolute value would make it positive.
Right. Those absolute values are going to ensure that the bottom is never a negative. So the only way that this situation could ever work is if the top is positive and the bottom is positive. Well, the bottom is always positive. We don't have to worry about that. These bars are going to ensure that the bottom is always positive. So what we have to do is make sure that this happens. We need to make sure the top is always a positive number. And as long as the top is a positive number, then the bottom automatically will be. And then a positive divided by a positive is going to be bigger than 0. So just figure out what numbers are going to guarantee the top is bigger than 0. So if you solve that, what do you get? X is greater than what?
3.
Negative 3.
No.
So if you plug in a number in the top that is bigger than negative 3, I guarantee this will come out positive. Now, x has to be greater than negative 3, but there is one number that's bigger than negative 3 that you cannot use in this problem. Yep.
2.
Right, you can't use 2. Why can't you use 2? If we plug 2 in the top, 2 plus 3 is 5, that's fine.
Because it'll make the bottom a 0.
Right, you'll
Can't
make
divide.
the bottom 0. You can't divide by 0. So you can pick any number that you want that's bigger than 3, but you can't pick 2. So if you want to think of it as a graph, here's negative 3, negative 2, negative 1, 0, 1, 2, 3. Can you pick negative 3 itself? No. So you can't pick negative 3, but you can pick anything that's higher except what number?
2.
You can't pick 2. That's what it would look like as a picture. Anything bigger than negative 3 except the number 2. So it's almost like it's actually broken into 2 pieces. You have piece 1 in that section that's connected, bounded, and piece 2 over here is unbounded. Any question on it? All right, so that covers everything in 2.4. Tomorrow we do have the picture day, so we're going to see what we get to. I'm not sure. 2.5 is definitely what we're going to start with, and we might start 3.1, but I don't know how much we'll finish. Okay, so that's the homework for tonight. Okay, so on page 108. Reminder that I will be after school on Thursday, if anybody needs to stay. Progress report's closed Friday, so anything you don't have done by then, I'm just going to be filling in zeros online in Aspen. I will update your homework average, participation, all of that will be updated on Friday, and this week's test will go on the progress report.